Good morning, children. Children, I welcome you all to today's session of science. And today we will be dealing with one of the most important chapters as far as the world of science is there, and that is force and the laws of motion. Now, this chapter you can say is directly dedicated to the great scientist Newton and all of his findings. You will find his presence everywhere in this chapter. So please follow me as I move ahead with this chapter. Now, your syllabus includes what is force, what is motion, Newton's laws of motion, action, and reaction. We will be covering all this inertia. See, it's all here. Your entire syllabus. Let me take it to this. Right, and momentum and force and acceleration and laws of conservation of momentum. Now, force. What is force? If in a playground when you kick a ball, it starts moving. If we do not kick it, it is there. It is stationary. But when we kick it, then it starts moving, right? And the direction of the ball is changed. In a cricket match, if we stop the moving ball, then uh, we feel something in our hand, and the ball is stopped, and its direction is also changed. Now, pushing, hitting, pulling objects are the way of bringing objects into motion. They move because we make a force act on them, right? We make a force act on them. Force can also make a moving body stop or change direction of motion. Thus, a force may be defined uh, as an external cause. See, force is defined as an external cause which changes or tends to change the state of any body. Right? It's an external cause which changes or tends to change its state of rest or uniform motion, direction of motion, or shape of the object. It's a vector quantity and its SI unit is Newton. Please remember this. Right. Now there are some effects of force which we should know. Right. Effects of force, that it can start or stop any motion. Force can change speed or direction. Force can bring change in dimension, and yeah, it can cause a change. Basically, it can cause a change in the form of motion, direction, and dimension. Now, force are balanced and unbalanced force. The balanced force is like in which the resultant of all the forces acting on a body is zero. See here, in this figure here, there is an upward reactionary force which is acting upward. Then this box experiences frictional force, right? Then we are pushing the box, so it is experiencing a push, and the weight of the box is acting downward. Now, if all these four are balanced, then this box will remain stationary. And if any of the side gets unbalanced, then it will move in the direction of the force, which is where it is less, the force is least. Right? The weight, see, it has been described here. Now, what are unbalanced force? The resultant of all the forces acting on a body is not zero. See here, there is force of push and the motion is moving upwards. The frictional force is in the opposite direction. There is a reaction here, weight here, but there are two forces. See, motion and force of our push, the two are acting on one direction, and they are not tried to be nullified by the force of friction, which is very less. Right. Now Galileo said, see children, we are here. Galileo said the objects move with constant speed when no force acts on them. Right? No force act on them means uh, there is an unbalanced force which is there. Okay. Now we move ahead and we see the differences between balanced and unbalanced forces. If the resultant of all the forces acting on a body is zero, the forces are called balanced. If the resultant is non-zero, it is called unbalanced. When the balanced forces are acting on a body, there is no change in its position of rest or uniform motion. When unbalanced forces act on a body, they produce change in its state or rest or uniform motion. Balanced force cannot change speed or direction of motion, whereas unbalanced forces, they can cause a change. Balanced forces can change the shape of the body. Unbalanced forces cannot change the shape of the body. They can only change the direction of speed or motion. Now we come to the Newton's laws of motion, right? This is super duper important, children. Super duper important. Not only in the theoretical part, but in the numerical part and in the practical day-to-day life, we see it quite frequently. We meet these laws. Now the first law is called the law of inertia. Now this inertia is defined as in the three ways. See, the types of inertia are defined as three: inertia of rest, inertia of motion, and inertia of direction. The first law states that an object continues to be in a state of rest or uniform motion along a straight line unless it is made to change in that state by a force applied on it. Right. Now what is inertia? See, it is written here. Inertia is the property of an object due to which it continues to be in a state of rest or a state of motion by itself. Right. It continues to be in a state of rest or motion, anything by itself. And these are the three situations of inertia. Now, inertia of rest is when a body is at rest and it cannot change its rest position. Right. Suppose, you see, there are certain examples of it. If a coin is lying over a table, it will not move unless and until we move it. Right. Inertia of motion. Right. Inertia of motion is with a ball. There are so many examples here given. Right. When a bullet is hit along a wooden board, then it comes to rest. It does not continues to move. Right. When a person is jumping out of a moving bus, he may fall forward. Right. Because the bus is moving. Right. And then inertia of direction is also now in Newton's second law of motion. We're on to this. It says that if you apply force to an object, then there will be a change in velocity. I accelerate in the direction of the force. So F is equal to, here the formula which will be derived is F will be equal to ma. Force is equal to mass into acceleration. Right. This you will be going to get. See here the derivation is there. F is equal to ma, that I told you. Force is equal to mass into acceleration. This is the Newton's second law. Right. The following examples are pushing a shopping cart. If you push a shopping cart that weighs slightly less than your weight, the cart will move, but the acceleration is limited. Piercing a bullet from a gun in an animal body. When a bullet is fired from a gun, the gases produced in the barrel exerts a tremendous force on the bullet, causing action force, and as a result, the bullet moves forward with a very high velocity. And when it pierces any body, it then slowly it retards and comes to an end. Right. Now, what is the unit of force? The unit of force is Newton. How you will define 1 Newton is that force which produces an acceleration of, see it is here children, 1 meter per second square in a body of mass 1 kg in the direction of applied force. And very importantly, these two units you should know. 1 kilogram weight is equal to 9.8 Newton and 1 Newton is equal to 10 to the power 5 dyne. Then we have momentum. Momentum is the product of mass and velocity. See, it is written here, momentum is the product of mass and velocity. Right. The relationship between force and momentum is F is equal to ma, and acceleration is velocity by time. So momentum divided by time becomes force. Right. You can see here change in momentum upon time is force applied. Now what is impulse of force? impulse of force is equal to the total change in momentum, that is force into time, is called the impulse of force. Now there are certain examples of this also. We are not going into detail, rather we are moving to the Newton's third law of motion, right? Newton's third law of motion. It states that to every action there is equal and opposite reaction. When we jump from anything, right, so we feel lot of pain in our leg, we feel the effect in our feet because the ground also exerts pressure on our feet. The flying of bird, when a bird flies, takes off, it pushes the air, pushes the ground, or whatever bark of tree or stem of tree it is sitting, it pushes it downwards and then it moves. Swimming, when a person is swimming, it pushes the water backward, and there are so many other examples of this. And the next is conservation of momentum, right? So conservation of momentum is called, if no external force acts on a system of two or more bodies, then total momentum of the system remains constant. See, it is here, right? This is called the law of conservation of momentum, and this is its derivation here and its formula here. m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2, and the recoil velocity of a gun is velocity is equal to mu by m. So with that we come to the end of this chapter. I hope you enjoyed this great chapter, force, and until we meet again, it's a goodbye.